Hello class, today we're talking about evaluating exponential growth and decay functions. Now we saw the exponential function the other day. We also dealt with values such as h and k. H and k are only really good for graphing functions that have been transformed in some manner. We don't generally work with h and k, so they're not going to be part of any of the problems we're doing today. But these problems usually come up when you're dealing with banking or investing. So these are the values and what they mean in terms of investing, but they can be done for other things, usually when the value of an item increases or decreases over time. Y will represent the final value of an item, whereas A represents the starting amount, or our y-intercept as we saw from the graph. B is the scale factor, which is how many times the starting amount is multiplied as you go up by one value to the right. So if we were to look at the graph of a function like y equals 1,000 times 2 to the x power, it would have a y-intercept at 1,000, and after 1 year, which is x, our time interval, it would multiply by the scale factor of 2, so it would go up to 2,000. And then after a second year, it would go to 4,000. It would double again. And we get this curve. We can go back in time as well. Maybe this was the cost of maybe this is the value of some item and it doubles in value every year. If you go back in time, it should also be losing value every year as well, which should make sense. But this is an example of exponential growth. There's two types of exponential functions. There's growth and decay. There are three possible outcomes for the b value. The b value cannot be less than or equal to 0. If b was equal to 0, the graph wouldn't be growing or decaying. It would just be gone. If it were negative, then the graph, every time the exponent went up by 1, it would multiply the number by a positive or negative number back and forth. So functions won't have 0 or negatives for exponential functions, because then the function won't be constantly growing or decaying. If you multiply by a number that is bigger than 1, the function will actually be increasing in value. So if I multiply any number by 1.0001, no matter how slightly bigger than 1 it is, it will be increasing. So exponential functions with a b value that is bigger than 1 are growing. When it's equal to 1, nothing's happening. So we don't really use 1 itself. If we are using a number to shrink a function, it has to be something that is smaller than 1 but bigger than 0, because 0, again, makes the function go away. A negative number would make the function alternate between positive and negative numbers, but a number between 0 and 1 means it will get smaller. So if I take any number and multiply it by 0.8, the number will get smaller. If I multiply it by 0.4, it will get smaller. So any number that is smaller than 1 but bigger than 0 will cause exponential decay. So let's take a look at a few examples over here. I have a few example exponential functions. This one has a b value of 2. Is 2 going to be an example of growth or decay? Well, it's an example of growth because 2 is bigger than 1. Will the second example be an example of growth or decay? It is an example of growth because 3/2 is bigger than 1. If the fraction were 2/3, it would be smaller than 1 and would be a decay function, meaning that the value would start at 3 and then go to 2 after 1 year. It would multiply by 2/3 and would be shrinking. Exponential decay functions look like this, and exponential growth functions look like this. The third example is a negative starting value, but it is still technically a decaying function because the b value is less than 1. This is a decay function. You'll often see examples written in this form, which is y is equal to a1 plus or minus r instead of b. So when you see 1.03, this is really like saying I start with 100%, which is the 1, and r is either it went up or down by a certain percentage. So in this example, we have 1.03, which is bigger than 1 by exactly 0.03, which is 3%. So this is actually growth of 3%. The next example, 0.95, is smaller than 1, so that is decay. Now, if you look at it in reference to this version of the formula, what percentage below 1 is that? It's 5% decay. It's decreasing by 5% per year, or whatever our x interval is. It could be a year, it could be days, it could be whatever value it says in a problem. We can rewrite 2 as 1 plus 1, which would be an increase of 100%. 1 is 100%. If you're not sure about percentages, you can just take whatever decimal you have here and multiply it by 100, or move the decimal point over 2 units to the right. So this is 1.0. So if we move the decimal 2 points to the right from 1.0, I'm sorry, to the right, we get 100. 3 halves can be rewritten as 1.5. So this is the increasing part of our function. So if we took 0.5 and moved the decimal over 2 places, that would be 50%. The next one is actually just 0.5. So this is smaller than 1. If we were to rewrite it as 1 minus 0.5, it would be the same thing. These would be equivalent. And that is a decay of 50%. It went down by 50%. All right. So we're going to take a look at an example. The example is that I'm going to invest $6,000 in an account that earns 3% annually. Annually is just a word in businesses with investments that means per year. There are other words. Twice per year is semi-annually. Quarterly means once, 4 times a year, or every 3 months. Monthly means 12 times a year, or every month. Weekly would be 52 times a year, or every week. Semi-weekly means every 2 weeks, meaning 26 times a year. Wondering if I forgot any of them. All right, so we'll continue. Oh, I guess there's semi-monthly, which means twice a month, which is similar to weekly, but it means it would increase less often. So weekly would be 52 times in a year, whereas semi-monthly would be 48 times in a year. It's normally good to try and increase the number of times interest is incurred. Let's take a look at our example. So it's $6,000 with an increase of 3%. So we want to know how much money we'll have in an account after 5 years. That is going to be Y, which is the final amount. We don't know what that is. We have a starting amount of $6,000. We are starting with 100%, and we are either going to increase or decrease by our percentage. It will be an increase of 3% over the course of 5 years. This is our how long we want to invest for. This is very easy to do. You just type this into your calculator and it will give you a value. So I'm going to do that now with my calculator. It's 6,000 times 1.03, or 1 plus 0.03. I have to put my exponent on it in the correct place. And if you do this correctly, you should get Y is equal to $6,556.36, and there's like a decimal value because of how exponential functions work. So because we are dealing with money, we only go 2 decimal places, so it's $6,556.36. If this number was higher, we would round it up, because if you were at any bank and you had approximately that much percentage of a penny left, they would just give you the penny if they rounded up. All right, how long would it take to have $12,000 in our account? Well, in this case, we're not trying to find how much we'll have. We know how much we'll have. We'll have $12,000. We're starting with $6,000. We're going to multiply by 1.03 to the x power. We don't know how many times or for how many years we're going to need. This is actually going to be some sort of decimal amount, some arbitrary random number of years. It's got to be bigger than 5, because when we put our money in for 5 years, we only got to $6,500. So we're going to try and use a logarithm to solve for the exponent. So the first thing we're going to do is we're going to divide both sides by 6,000 so that we can get into exponential form. So if we do that, we will get that 2 is equal to 1.03 to the x power. And there are two ways to use log form. We can either use log base if our calculator allows log base. It would be log of base 1.03 of 2 is equal to x. So I'm just going to use a calculator for that now. On my calculator, I type log base, I type in 1.03, and I want it to equal 2, and that will happen after x is equal to 23.4497 years. So around 23.5 years approximately is how long it'll take. What you should write for your answer will be determined by the question that you're asked on a test. I will let you guys know in class if I did not specify on a worksheet. We also could have done this using the laws of logarithms that we've covered in a previous class. One of the things you're allowed to do is you're allowed to write log on both sides of your equation. So you can write log 2 is equal to log 1.03 to the x power. So we're going to write log on both sides of the equation. We're actually going to use the power rule to move the exponent out as a coefficient. We're going to get log 2 is equal to x log 1.03. And then we are going to divide both sides by log 1.03. This will cancel out, so x is equal to this value, which if we use a calculator, should be the exact same amount as it was when we used log base. Because this is the change of base formula, this log expression is actually equal to this log expression. So they should both give you 23.449 years. We have another question, which is, how much should I invest in order to earn $15,000 in 8 years? So this one is implying that we're not actually going to be investing $6,000. We're going to start with $15,000. We're going to invest some amount we don't know. That's A. We know that the interest rate for this particular bank is 0.03, and we are going to be putting our money in for 8 years. So we're just going to try and solve for the amount that's missing in this case. So the way we're going to do that is we're going to just divide both sides by 1.03 to the 8th. 1.03 to the 8th. These will just cancel out. And then we just have to type this in our calculator and we'll know what the amount we should really invest is. Instead of $6,000, what should we invest? I'm just going to use my calculator now. 15,000 divided by 1.03 to the power of 8 is $11,841 and 138 cents. So that will be the value that we should have started with if we wanted to earn $15,000. So that would be $11,841, and I would round that up to a 14 cents because if we do it under 14 cents, we won't earn $15,000. We'll be short. All right, if you have any questions, make sure to ask me in class.